A really interesting indicator can be made using red cabbage. What I've done here is take some leaves of red cabbage and cut them up with a pair of scissors into smaller pieces, and the smaller you make them, the easier it is to extract the chemicals from the leaves. And then I boiled the beaker containing the cabbage leaves with water in a microwave oven for a few minutes to extract some of the chemicals from the red cabbage. Now pour some of the red cabbage solution into different test tubes. So here we have some test tubes with red cabbage solution in them. To one test tube, I'll add a small amount of baking soda. So there's our baking soda. To another one, I'll add a small amount of the vinegar, which I've poured into this little beaker. That beautiful color. To the third test tube, I'll add some household ammonia, which I have in a dropper bottle. And we mix that up, and we get a nice green color. And then to the last one, I'll add some hydrochloric acid or muriatic acid, a 1 in 10 dilution. And here we have a common substance, red cabbage, showing completely different colors with different substances. So this is vinegar, this is hydrochloric acid, this is baking soda, and this is ammonia. And these are really different strengths of acids. Hydrochloric acid is a very strong acid. Vinegar is a weak acid. Sodium bicarbonate or baking soda is a weak base. Ammonia is a stronger base. Then I have a fifth test tube in which I'll add some sodium hydroxide, which we can obtain from Drano. And Drano is also a strong base, a little stronger than the household ammonia. So we see some beautiful colors as we change the pH of the red cabbage solution. So just to summarize the range of colors that we get, this is the strong acid, this is with vinegar, this is the solution without any acid or base added, that's straight from the beaker, with the boiled red cabbage. This is with sodium bicarbonate, or baking soda. This is with household ammonia, and this is with sodium hydroxide or Drano. And you can see we get quite a range from a strong acid to a strong base. A beautiful range of colors. So here I have a beaker full of the red cabbage juice, and I'll add a few drops of the hydrochloric acid to that. And stir that with the glass stir bar. And you can see that the solution turns nice and red. Now we'll add a solution of sodium hydroxide, also known as Drano, and then we'll add that drop by drop to the solution. So what I'm doing is adding a base to an acid. And you can see where the drop of sodium hydroxide goes into the solution, we get a dark color, a dark blue color, almost immediately being formed. This is often called a titration, when I'm adding an acid to a base, or vice versa, in small amounts, and then using an indicator, in this case the red cabbage, to show when the color changes or when the pH changes. And right now we're getting close to a neutral solution. Kind of a purplish solution, mauve solution. Now it's getting kind of greenish, blue-green solution. So now we're getting to a basic solution. And if I add a large excess of the base, we eventually get a nice blue solution or green solution, indicative then of the basic conditions. One of the things that cooks often do is to add a small amount of acid or base to the food. In the case of red cabbage, if you want to make it look kind of blah, you leave it neutral. If you want to make it look more red, you add a small amount of vinegar to the red cabbage to give it that reddish color that's often associated with the red cabbage. If you add baking soda to it, it makes it go kind of greenish in color and maybe not quite as appetizing.